I have a little piece that's a little different prepared for that, but I will speak since we're talking about prediction, just to jump in. So from the brain imaging and mental health perspective in terms of using AI for predictive features, I'm not saying that, where I work over in San Antonio at the Research and Imaging Institute, that we envision a world where everyone gets a brain scan if you're having mental health concerns. Brain scans are expensive and timely. That doesn't really make sense, but what we hope to do is use these methods to help us learn about, why do some people get sick but others don't? What does a healthy brain look like compared to a recovered brain, compared to a brain that's never been sick at all? So in addition to helping improve our diagnoses, treatment is a really, really big one. So that is a predictor that we're looking for. In depression in particular, fewer than 40% of patients achieve remission after their first try at medication. So you've probably heard all the commercials of all the different medications are out there. So you have a very poor likelihood of even responding to your medication. And of all those that are available, does anyone want to guess how your physician chooses which one you try? It's usually the one with the least side effects. So the harshest medication that's out there, they say, well, we'll go ahead and try this. And those of you may know, it takes about, how long does it take for an SSRI to kick in? Is anybody familiar? It's weeks. It's between 2 to 3 weeks. So that means you're being prescribed a medication that's going to take that long to work, if it will. So you have patients that are sick for a long time. We're doing this trial and error thing with medication. So an idea would be to use AI to help, use predictions. And then perhaps do gene association, since I said we're not going to do a brain scan on everybody, but if we can use unsupervised AI to help, can we take your blood and maybe infer, are you a Prozac person or a Lexapro type person? Those are the kind of predictors we're looking for from brain imaging and using AI, since again, like Bob said, we don't know what we're looking for just yet. So that's our perspective from the brain and imaging.
And that's called precision medicine, by the way. That is, you're trying to tailor a therapy to the actual patient. Remember, we go by randomized controlled trials as the gold standard, but they're not perfect because there's got to be some patients that just don't fit. That the drug actually did help them, or it actually made them sick, and they just don't fit the rest of the group. So the whole goal there, to me, and this is where I think one of the next steps will be, is to combine all the data together, phenotypical, which is what's in the electronic health record, genotypical, and Lord knows what else. Put them all together. Why don't we analyze an EKG and an echocardiogram together? Why don't we analyze an EEG and a functional MRI together? I mean, in other words, the combinations to me is probably where the goal will be. Now, however, somebody's going to have to pay for that. There are plenty of challenges that face us, but it's also exciting stuff.